All right, everybody, why don't we go and get started? This is the only thing standing in your way between now and a great attendee party, so I appreciate your attendance. Want to get you started on time and get you out of here on time. So, welcome to SBC 206. This is about automating SharePoint 2013 deployments for disaster recovery using Windows Azure and Cloud packs. My name is Tom Wisnowski. I'm an enterprise architect with Microsoft Services. With me, I have some colleagues.
I'm Alex Lee, architect at Microsoft in the Data Center Center of Excellence.
I'm Srikanth Gupta, SharePoint Senior Premier Field Engineer based out of Houston, Texas.
And today we're going to be talking to you about some of the tools and services and capabilities that we have both in the product and in services to help you automate your environments for disaster recovery. Okay, so before we begin, again, reminder, this is a 206 session. If you've seen me in some of my previous SBC sessions, I typically do level 300, 400 type talks. Today we're going to keep a little bit higher level, right? So we're going to be talking about concepts, logical architecture. If you're here expecting to see some deep PowerShell, maybe some network traces, not going to happen now. But please, if you do have some deeper technical questions, grab any one of us after the session, and we're going to be more than willing to help. So, a lot of people, ask, why is it important to consider business continuity, right? Why do we really need disaster recovery? And I typically respond to that question with a question, and it's simply, what's built on top of your platform, right? So if you think about it, SharePoint is a service. That's the common approach we take today in IT. Do you really know what's in your SharePoint environment? Now, you may say, yes, we have data governance policies. We say that, maybe business critical data is in our SharePoint environment because we don't have disaster recovery. But if you really think about the breadth of the platform, the amount of content you have to manage, and I've talked to many of you throughout the conference, and now it's very common to see these, tens of terabytes of content and data in these platforms. How do you know that all that content is not business critical, right? Do you know that potentially maybe there is some financial department that stored their next 10K that they're going to take to market, the draft that is the only copy in the entire enterprise? The reality is we don't know. And the risk is it's really around customer expectation, right? So consumers today, us included, we live in a world of 24/7 online services, right? So things that we use every day like Outlook.com, OneDrive, Facebook, Twitter, these things are always on. Our data is always there, right? Regardless of if it's our favorite picture of our kitty cat or if it's that mission-critical Excel worksheet, it doesn't matter, right? The data is always there. And we don't have to do anything or even think about it, right? Every time we go back to our OneDrive, there's our files. Every time we go back to Facebook, there's our memories. Consumers have those same expectations when they come into the environment. When they're connecting to our services and our systems, they're thinking along those same lines. Yeah, if I put this up in SharePoint, it's going to be there tomorrow. So it's critically important for us to really consider implementing a disaster recovery plan and business continuity plans when we're building our SharePoint environments. So if it is so mission critical, why don't we do that today, right? So I have talked to many people and they say, I've taken a look at the guidance that you guys have on TechNet. This is really complex. There's all these moving parts. It seems really expensive. We don't really know how to do it. There's just so much cost and risk, and we really don't see the benefit because, you know what? A disaster will never happen to us. We live in some magical place where there's no database or data center disasters. Well, so through today's talk, I would like to address each one of these issues, and hopefully you'll see that through the technologies that we're enabling today and some of these support statements that we're releasing this week, in addition to some of the IP that we have, we're going to make this low cost and very efficient, very effective. So our hero of the conversation is Azure. So how many people here actively use Azure, whether it be IaaS, platform as a service? Okay, a few people. Okay, great to see hands going up. Azure is the perfect environment for a disaster recovery environment. If you think about it, there's some key quality attributes. One, it's cloud hosted, right? It's out of your data center. You don't have to worry about rack, stack, and cable. You don't have to worry about the cost of operations. It's low cost. So if you're not aware, if you're spinning up virtual machines in the cloud and you're shutting those down through the portal, then they're actually turned off, you're not paying for those machines. You're paying just for the little bit of storage that those machines require, and that's it. That's a big difference when you look at the cost saves compared to your on-premises costs. It's fully integrated. So we can take your Azure environment, we can fully integrate it with your data center and make it a seamless experience through virtual private networks, through ExpressRoute and new MPLS options. We have the ability of virtually extending your data center to make this completely seamless. Agility, right? So how many people here can deploy a SharePoint farm in a day, right? Infrastructure procured, everything ready to go. Your data center has the excess capacity. Okay, a few of you, that's good. Most of the time, at least the customers that I deal with, typically that takes a little bit longer than a day, right? Sometimes we've got to go through procurement cycles, we've got to provision infrastructure, get virtual machines up and running. In Azure, you always have the excess capacity. And then finally, this is going to be fully supported, right? So you be rest assured that if you deploy your SharePoint infrastructure, your production infrastructure in IaaS, that we are going to support you. Right? If you run into issues, we will come back and we'll make sure we resolve those issues for you. So let's dive into the costs. So I think the costs are probably the most interesting factor to consider. So if you look at an example environment, right, and this is actually based on our product line architecture, you can see on the left-hand side, I've got a typical farm. We've got Office Web Apps farm. We've got multi-server topology for SharePoint, and then we've got a SQL backend. Now, when we're calculating costs, a couple things to consider. First, what DR approach are we going to use? In this case, we're going to go with a cold standby. So this means that I'm going to shut down non-critical systems as often as I can to lower overall costs. With that, on the SQL side, we're going to use a technology called Always On. I'm sure you've heard a lot about this over the past day or so. We're going to use Always On for our replication architecture. Now, from a cold standby standpoint, we have a schedule that we're going to follow, and this is how we're going to calculate costs. So on the SQL side, we're going to run at least one instance 24/7. This is because in our Always On cluster, you're going to see that we're going to constantly keep that on so we can replicate traffic 24/7. On the SharePoint and the remaining SQL servers, we're going to go ahead and have a warm schedule, if you will. So we periodically want to spin up this environment. We want to make sure that we're deploying change, patches. We want to make sure we're warming it up to make sure that we keep domain trust going between these servers. So we're going to assume that 16 hours a week on average, we're going to spin these machines up and then shut them down. And then all servers in the environment, we're going to assume at least twice a year, we're going to take a week and we're going to go through full DR failover testing. So if we look at the costs, assuming that schedule, and you can replicate this yourself, go out to the public Azure website, use the cost calculators, and you can come up with these numbers as well. You basically come up with roughly around $50,000-ish, right, for that infrastructure running on that schedule. And that's a pretty good cost saves. Now let's take a look at the on-prem side. So on the on-prem side, we're going to make some assumptions. So first, we have the same architecture, but we're going to assume that this virtualized footprint, we're going to run on a minimum of 3 physical hosts. Now, you might actually want to run this on more physical hosts for better availability, but we're going to go with 3 for right now. On the cost side, I'm going to make an assumption here and say roughly we have a 4-year depreciation model, and it's going to cost about $500 a month for these machines. That includes the cost of the infrastructure, the operations, support, everything that we typically provide, fairly common if we've outsourced IT. On the storage side, SAN, typical sort of middle-of-the-road Tier 2 storage, we'll go with 45 cents a gig. Your mileage may vary. You can plug in your own numbers. So if you calculate the costs, servers, storage included, network costs, Premier support, so again, assuming that you're going to want support on both sides, you come out to quite a bigger number than the Azure scenario, right? So roughly about $170,000. So from an ROI standpoint, right, when I'm talking to a CFO, which one do you think he wants to go with? Right, the Azure, which I can run intermittently in a cold standby for $50,000, or 3 times the cost constantly running it on-prem. And that, to me, I think Azure is something I definitely would consider. So, Azure, what do you need to know? Right, so if you're not familiar with the Azure concepts, if you're going to be standing up SharePoint, a few key things you need to keep in mind. So one, we're going to be deploying SharePoint on top of virtual machine infrastructure. This is infrastructure as a service. We're not going to be using web and worker roles. SharePoint doesn't support that. So we're going on virtual infrastructure. Cloud services and the cloud services architecture is important. If you're looking at SQL Always On in Azure, we're going to want to go ahead and plan out our cloud services appropriately, making sure that the SQL servers are in their own cloud service. We'll talk about that in a minute. Azure networking, right? So at the end of the day, we're extending our data center. So we've got a few options now. We have the VPN capability, and also in preview, now we have Express Route, right? So MPLS options. And then finally, obviously, storage, right? So to make all this happen, virtual machine storage, data storage, et cetera. So let's go through the concept. So first, we have an on-premises environment, fairly typical, right? We've got a SharePoint farm, we've got Office web apps, we've got directory infrastructure, network, our content, service application, data. So the first thing we're going to do is we're going to extend that data center. We're going to extend it out into Azure. This is what we call the hybrid architecture. First thing we do to do this is we establish that network connectivity, right? So in most cases, it's going to be a VPN, but it could be MPLS if you're in the preview. All right, once we have that connectivity, next thing we need, because we've decided that we're going to go with an always-on approach, is we have to extend our directory structure out into Azure. Now, in this example, what I'm doing is I'm taking the on-premises domain for us, extending it out. There are other options you can consider. So, for instance, a resource forest model where you establish a directory in Azure and then you pull it in. Different options, pros and cons. We can talk about each after the session. Okay, so once we've set up the secondary AD site, we make sure AD replication is working correctly. And then finally, we can stand up our infrastructure, right? Joining those DR servers to the same domain, establishing the SQL always-on implementation. And then finally, with always-on, replicate the databases that support replication. So the deployment process. So the first thing we have to do is provision infrastructure. We have lots of different tools in our tool belt to do this. So if you haven't heard, we have this option called Cloud Packs. Cloud Packs are an automation tool to help you stand up SharePoint environments. They're based on our prescriptive architecture, which is product line architecture, but it can be extended to meet your needs. We also have an Azure portal option. Then as we go through the process, we're going to talk a little bit about how we validate environments, and then so we have new RAP as a service tools at your disposal. Then finally, we'll talk about how we actually configure the Azure infrastructure and always-on environments, and again, through tools like Azure Portal and PowerShell. So we're going to now deep dive in each one of these areas. So now I'd like to pass the mic, and we're going to talk about provisioning environments. So before I pass the mic, just want to make a brief mention. So the first thing we do to accelerate your builds is we have an option for you if you haven't designed your 2013 environment, or maybe you're thinking about taking a different approach. We have something called product line architecture. So product line architecture, we're not going to spend too much time on this. The idea is it's a prepackaged, predefined approach to doing SharePoint services on premises, similar to what you would experience in Office 365, where you have a preset service description, SLAs. We've done the same now for an architecture on-prem, and this can help accelerate your design and deployment. We have recently just launched PLA version 2.2, so this is a living, breathing architecture. So every time we're getting feedback from the field, we get feedback from Office 365. We're implementing minor changes, always constantly looking to improve that approach. And so now I'd like to pass the mic to talk about Cloud Packs.
Thanks, Tom. So as Tom mentioned, we have Cloud Packs. It is a set of automation. It's pretty lightweight use of System Center and what I like to call a data-driven approach to, or data-driven deployment methodology to building your farm. So what it does is enable rapid, repeatable, and predictable deployments. Data-driven, the data that you would supply would be things like domain names, server names, maybe SQL ports, that type of thing. But we don't really necessarily redefine the topology, right? So if it's a PLA environment, it's a 7-server environment with 2 front ends and 3 back ends and 2 SQL plus the witness. That never changes, so you're assured that every time you build an environment, it's the same. So as you move from dev to test to prod, or if you have multiple tenants, if you're a service provider, or you have different business units that want different types of SharePoint, or SharePoint for different uses in their own, that's what Cloud Packs exists to do, is to help you deploy the PLA, product line architecture design of SharePoint. And that's what we ship with standard. It is possible to go in and customize it to deploy whatever your particular design for SharePoint happens to be. Maybe it's just a 2-server design, it's a little test bed or development environment. So we can do that. It takes a little more work because we don't have all the automation in place. We don't have all the scripts in place for any possible design of SharePoint. Just a couple. So it exists for on-premise today. the Azure IaaS piece we're working on right now. It should release by the end of, this is March, the end of March, 3 weeks. And this is what's in the environment, right? So we have a portal to interact with it. We provide an ASP.NET sample portal. We can work with you to work into your portal. We can also work with Windows Azure Pack as a portal. We have a little database, orchestrator, a deployment share at the bottom, which is just a file share. And then for on-premise, we require VMM, right? So that's how we actually spin up the application topology, create the VMs. And then the VMs will execute the task sequence and scripts that are in the deployment share. And so this is the environment. I took it from one of Tom's earlier slides for the PLA. And now we can also go to Azure IaaS. And so if we're deploying Azure IaaS, we don't need VMM, because VMM can't actually talk to Azure IaaS. And we can spin up the same environment. Ultimately, in a deployment share at the application level, it's the exact same set of scripts. At the orchestration level, it's almost the exact same runbook. There's a couple changes in there because of the difference between VMM and Azure IaaS. And then, as Tom mentioned, hook up the network in the Active Directory, and now you have this DR environment ready to go. So I mentioned it was a deployment methodology. So again, in the middle, we have the Cloud Pak environments, and there's sort of 3 sets of functions that I like to think about. There's define and request, deploy and monitor, install and configure. And so for define and request, one of the things that we thought of was that there's this notion of 2 personas who are involved with the deployment of a SharePoint farm, right? So there's a fabric administrator, a Cloud Pak architect who knows what the farm should look like, right? It's the 7 particular servers. It should be deployed to, if it's on-premise, maybe it's your Las Vegas data center. If it's in Azure IaaS, then maybe it's in Windows Azure West data center. Or maybe you want it on Azure East so that you have some geo, I don't know, in case you lose the Western Seaboard or something. But then there's also a deployment engineer, right? Somebody who's a junior level admin, maybe doesn't know SharePoint, maybe doesn't really know all the particulars of your data center. And so they can deploy what a service designer has already defined. And that definition is the topology and the location. And we use VMM user roles for on-premise to control what access the service or the deployment engineer has. So if you are a service provider and you have multiple customers, maybe you have admins who work on Coke. Those admins can't work on Pepsi, right? So you get some separation there. In the middle, we have deploy and monitor, and that's what we use Orchestrator for. We don't reach deep into the VMs in the SharePoint environment. And so we really just orchestrate the deployment process. So the runbook looks for a database entry that says there's a deployment request, tells VMM or Azure IaaS to create the VMs, and then as the VMs come up, the script, the application installation and configuration logic is in each of the VMs. So we can inject configuration data in, and then retrieve status out of the VMs and display them in the portal. And this last piece is the deployment share, where we have all the application-specific logic. And I call it a framework. We have a pretty modular approach. These are the same 3 functions. And you can see a few of the things that are responsible for delivering the functionality in there. And so what you see here is our first shot at it, which was on-premise SharePoint farms. And so for the deploy to Azure IaaS scenario, we made some changes to the ASP.NET portal. We have some work to do to merge them down, but it's just a little bit of change to the portal. In the middle is where it really changed, right? The deployment process for Azure IaaS is very different from VMM. Azure IaaS has no idea what a service template is, a VMM service template is. There's fewer choices in Azure IaaS, right? So you pick a t-shirt size VM, there's one network. Azure does things with on10.xml that we don't have control over, so we have to work around that. And for moving data in and out of the machines, the VMs on-premise, we use Hyper-V key value pairs to write and read from the registry inside the VM. And we don't have that in Azure IaaS. So without changing the application-specific logic, a little bit of change in the portal, mostly it was all in the deploy and monitor phase, which is very different for Azure IaaS. Similarly for Windows Azure Pack, has anybody worked with Windows Azure Pack or heard about it? Okay. Even less change. All we had to do was change the portal. So we take the ASP.NET out. There's a bunch of work within Windows Azure Pack, but we can light it up that way. And in the future, if you notice the previous slides, we didn't touch the installation and configuration piece. It's a task sequence and a bunch of scripts. It hasn't changed in a while. So there are some new things coming with PowerShell desired state configuration. Is anybody aware of? Okay. So that has the potential to be very cool. We don't know exactly how we're going to get there, but we are starting to move in that direction. We need providers and things like that. So that's a handful of slides about what Cloud Paks are. I have a couple videos here actually to show you what the experience looks like. We didn't do live just because it takes a couple hours to deploy a farm, and as I like to say, deployment demos are pretty boring because you create the VM and then it does stuff and you can't do anything for a couple hours. So we recorded it. There's some fast forwarding or time lapse type of thing, and I'm a really bad video editor, so. Oh, sorry. So this first one is the deployment experience. Remember I spoke of the service designer and the deployment engineer, so this would be the junior admin who gets a ticket, says, build a farm. So we want to select an Azure subscription. We want to select a defined Cloud Pak, and it's reading the service templates to define these are the 7 servers, provide the computer names. Click next, and the next screen. So this is entrance criteria, or pre-provisioning checklist. That's just a sample. We would want to work with you to define whatever your processes are so that it works with how you guys actually deploy farms. And then there's a bunch of configuration data here. Passwords, product keys, paths. All of this information can be supplied in configuration files. You don't have to require data entry like we were just showing in the portal. We do that for demo purpose just to show that we can interact. So, especially if you're in a dev environment and you want to just give it to your devs and say, yeah, go build whatever you want to build over there, then you don't care about it, right? And they're responsible for names and things of that nature. And so here we've clicked submit. There's a green line that says the provisioning has been successful, and what we've done behind the scenes in the portal is write a database entry that says new deployment request and created a folder for that specific deployment request and copied all that data in. So the default configuration files plus the data that we took out of the portal, and we will later use that when we spin up the VMs to merge those 2 sets of data and get the correct configuration information into the correct VMs. So now some time has passed, and we'll show you a really quick video of we're deployed to Azure IaaS. So here you can see the Windows Azure portal. We'll zoom in a little bit on the 7 servers that we created. And then we're going to log into one of the servers and show you the central admin page with the SharePoint services running. I apologize for not capturing anything in the middle when it was building. I set it to go and then I forgot. Like I said, deployment's boring. When it's actually deploying. It's exciting when you're trying to get it to work.
But it's nice in fact that you could actually walk away from your deployment script and it actually functions without any issue.
Yeah, that's great when it's almost magical sometimes when it happens, honestly. But it's good. So here's a little bit under the hood. I talked about the application topology, and there's a VMM service template, and Azure IaaS doesn't know what that is. And then there's some other things that we need for Azure IaaS, right? There's an image and service, cloud service, and things of that nature. So this video will walk through some of that pretty quickly. Here, the Azure IaaS service template is CSV. You can see server name, you can see image name, you can see availability set. We specify the disks. There's log 1 and 2 and a couple other things there. Some endpoints were specified. These are the images that we stored in Azure. And then coming up should be the services. So we're going to highlight the SharePoint service and the database service. There's AD service as well. We didn't draw the box around it. Here's the VPN. So it takes a little work to set up, just like on-premise. It's not, just magic, go ahead and do it. One of the things that we did to get to, so here's configuration files. This first one we're going to show you actually controls what you see in the portal. So you could request less information, and then this last one is for a particular server type, and you can see there's a bunch of replace keywords in there, and that's how we inject the correct data for the environment. Yeah, so one of the things we did was the on-premise Cloud Pak for SharePoint has existed for, I guess, released for about 6 months. It's existed for a little longer than that, and when Tom asked us about Azure Eyes, we were like, I don't know, let's see. And so it's working. There's a couple things we want to get to. So when we're showing you the image and the site-to-site VPN and the service groups, cloud services and the endpoints, those are things that we would want to bring in at some point just to continue streamlining the end-to-end and add more things into it. So if you're interested, you can contact your service executive. I'm here all week. You can find me. If you want to get into a deeper demo, we can also do that this week. Cool. And so Sri's going to talk about RAP as a service.
So thank you, Alex. So we'll now discuss about the process of assessing risk and validating the forms that are deployed using the Cloud Paks. Okay? So after you provision your production form and the DR form with the help of the Cloud Paks, how can you be sure that these forms still comply to the PLA specifications, right? For that matter, even during your day-to-day operations, you want to be certain that both the forms still comply to the PLA guidelines, right? So to help you with that, we have come up with a toolset called SPRAS PLA toolset. So all you do is you execute this toolset against the forms, which captures the data about your form and then fires the issues, basically the PLA checks that are not in line with the PLA guidelines. This toolset will be made available to you as part of our SPRAS service offering. Now, what is the SPRAS service offering? It is one of the most popular surveys that is available from Microsoft Premier Services and is delivered to Microsoft Premier customers. Okay? So to give you a little bit history about this SPRAS service, it all started about 10 years back maybe with a service offering called SharePoint Health Check, which then transformed to SharePoint Risk and Health Assessment Program, famously known as RAPS. The current version of the RAP is what we call as RAP as a service, simply called as RAS. Like platform as a service, infrastructure as a service, software as a service, RAP as a service. So RAS is our cloud-based solution to conduct risk and health assessments on your SharePoint forms. As of today, there are over 19 different Microsoft technologies that are RAS enabled, and now we have come up with a PLA version of the RAS. So the idea behind SPRAS revolves around 4 different phases. Phase 1 being assessing the current state of your environment. So this is done by executing the toolset against your environment, which does some data collection and then fires the issues. Those issues are further analyzed by one of our Microsoft SME, and then the SME will provide an initial findings session with the help of a closeout call. That the closeout call can happen either on-site at your place or can be happen remotely. The phase 2 actually involves a remediation planning session. During this session, the SME will help you in identifying suitable resources and also solutions to fix the issues that are identified in phase 1. Phase 3 involves remediation execution, meaning you will implement the solutions that you have previously identified for the issues that are filed. And of course, after you implement the solutions, you would definitely want to reassess your environment to see where you stand as of today when compared to the previous run, right? That's when you rerun the toolset against your environment, and then you'll be able to do a delta comparison between the first run and the second run. So it is almost possible that when you rerun the toolset the second time, you might find some brand new issues that were not originally shown up during the first run, at which point, again, you take the circular approach of doing a remediation planning session and again a remediation execution and followed by reassessment. So as you can see, the idea of SPRAS itself follows a circular approach, thereby helping you to keep the number of issues to as minimal as possible and also letting you maintain a healthier and cleaner SharePoint environment. So once the assessment is completed, the overall results of the assessment are actually broken down into 2 main pieces. One is called health results, the other one is called risk results. Health issues pertain to the current state of your environment, whereas risk issues pertain to the future state of your environment. For example, there are some timer jobs that are failing in your environment. We flag it as a health issue. The lack of database maintenance plans around the SharePoint databases are actually flagged as a risk issue because they may potentially induce some problems in future, right? So that's the difference. So now that I have introduced you to the SPRAS toolset itself and the service offering, and we have seen the process flow, right? let's actually look into the SPRAS toolset flow itself. So let's say you have set up your environment with the help of the Cloud Pak. So how can you validate this environment if the environment complies to the PLA guidelines, right? So you set up a machine called tool server that is not part of your SharePoint environment, a separate server altogether, but is still joined to the same domain as of your SharePoint farm. And then we provision an assessment site for you on the web, on the RAS web, from where you can download the toolset and upload the results back to the cloud. There are certain prerequisites that you have to implement on the tool server even before you start installing the toolset and do the data collection. Part of the prerequisite implementation requires you to setting up a remote PowerShell between the tool server and one of the server in your SharePoint farm, which we call as target server. In our case, in this example, let's say SPPLA app N is our target server. So after you make sure that the prerequisites are implemented, you are good to download the tool set from the web. So you download the tool set and you install it on the tool server. And then you run it against your SharePoint farm by specifying that app N is going to be your target server. With the help of the app N, the toolset then discovers the rest of the servers in your environment. And then it starts the data collection by executing a series of PowerShell scripts, SQL scripts, and WMI queries. The collected data is then transferred over back to the tool server from your farm. And now we are ready to upload this data back to the cloud with the help of the toolset. And the data is now uploaded to the cloud. This submission process actually goes over through an SSL, so it is secured. Secondly, the data is encrypted even before it gets submitted to the cloud, so that provides an additional layer of security. Each and every customer's data is actually stored in a separate SQL Azure database to protect your privacy. And more importantly, we don't collect any passwords from your environment. All such data is trimmed even before it is submitted to the cloud. So once the data is submitted to the cloud, our automated analysis engine triggers automatically and then analyzes the collected data and fires the issues according to the PLA checks. Now these issues are again analyzed by one of our SME to provide you the findings. The website also provides you the functionality to generate the reports for the issues that are filed. So this is a very, very high level, conceptual overview of how the SPRAS toolset and the process works. So to sum it up, you collect the data against your environment by running the toolset, you submit it to the cloud via some secure channels, and then you'll be able to view the results almost immediately, which are available for you 24/7, anytime on the web. And then our SME will advise you about the remediation planning for the issues. And finally, you will be able to rerun this toolset as many number of times as possible and submit the data as many number of times as possible throughout your subscription period, which is 12 months. And most importantly, right, you'll also be able to take advantage of our continuous updates that we push to the toolset as it is located on the cloud. So that's another added advantage. Let's now look at some of the screenshots of the SPRAS toolset itself. That is, this is the PLA version of the SPRAS toolset, by the way. So this is a start page of the toolset that is fired on the tool server. And we are telling that we wanted to do some collection from this server. On the second screen, you specify the name of your target server. In our case, it is our SPPLA app N server. The other two options that you see on the screen does some prereq validation. With the help of app N, the toolset then discovers the rest of the servers in your environment. Once discovered, the toolset then starts collecting the data against your environment. What you see on the screen right under the scroll bar is the name of the collector, so you will see the collector names changing under the scroll bar there, under the progress bar there. So once the collection is done, we are now good to submit the data to the cloud, which requires a submission access key that is available on the RAS web portal, by the way. It is this submission access key that is used to encrypt the data before the submission happens. And just in case if your tool server does not have an internet connection, right, you can export the collected data to other server and import it from there and then submit it to the cloud. So with that said, let's have a quick demo of the SPRAS portal itself. So this is the landing page of the SPRAS portal. I go to new and active. By the way, this view may be different for you as a customer, but more or less it should match. So what is loading now is the issues list screen that should display the list of issues in your, as part of the assessment. Okay. So I have it already loaded. So this is how the issue screen looks like. On the left-hand side, you see two severity levels, like critical and high. Actually, there are three more that are currently not showing because there were no issues that belongs to other three categories. So there are 5 severities in total: critical, high, medium, low, and informational. In this test assessment that I have done, there were no medium, low, or informational issues that are fired. All the issues that are fired are of type critical and high severity only. So under critical, you'll see the list of all the issues. By clicking which, you should be able to see the issue title itself, a short description, and the objects on which the issue is filed. Okay? This is the place from where you can look at the reports that are created. You'll not be able to create the reports by yourself. The SME who is going to analyze the issues, right, he will be generating the reports, but you will be able to download them from this web. We provide you 3 types of reports: the Excel sheet list of all the issues that are identified, a Word document containing all these issues that are identified with a very detailed description, best practice text, etc., and finally a PowerPoint presentation for the executive summary. So that's all from my side about the demo. So let's switching back. So how can you take advantage of this SPRAS service? Please get in touch with your Microsoft Technical Account Manager or the Service Delivery Manager. They should be able to help you in signing up for the SPRAS service. Over to Tom to speak about the DR setup.
All right, so now let's get back to DR. Okay, so now that we've provisioned some environments, right, we've got an on-premises environment, we've got the cloud environment, we've validated both, we're confident things are happy and healthy. Now it's time to actually configure always on, get DR replication working, and then talk about the DR failover process if we ever have to leverage it. Okay, so the first thing we want to announce, and I'm sure you've probably already heard this, is we finally do have support for async replicas for SharePoint databases. Well, pretty much mostly all of them, minus a synchronization database and our search databases. So this is actually something that we've been waiting for a while. If you've been out to TechNet, I'm sure you've probably read through our database guidance on how to replicate, and mysteriously it says, well, we're working on it, right? We support content, everything else, we're still testing. Well, you'll be happy to know that we fully support async replica, which is great. The awesome thing about this is now, with Always On, you have one technology for high availability and disaster recovery. So if you were implementing maybe Always On for HA, but then you had some sort of log shipping architecture or other replication, more moving components, more complexity, this is a much nicer solution. No need for log shipping, so if you've gone down the log shipping route, maybe you implemented DFSR, all those moving components are gone. And in addition, you'll learn throughout the week that we've also made improvements in the SharePoint product to better support always-on availability. Okay, so what do we replicate? So again, we don't replicate all of the databases in the environment. So in particular, definitely not the configuration, the admin content databases, your sync database for UPA, your databases for search. Typically, you're not going to be replicating those, and usually not because they're not supported. With those services, there are approaches to consider to have an always-on or at least a highly available service. For instance, for search, we do have approaches where obviously you can use backup and restore for full fidelity, or you could potentially explore options where your disaster recovery environment crawls your production live environment. But other than that, pretty much all the other databases do support it. Some of the databases that are supported may not even make sense. For instance, the Power Pivot database. That's just transient data that's there when you're viewing a Power Pivot workbook. Really, I wouldn't replicate it, but we have tested it. It does work, and so we do support it. Okay, so now let's talk big picture, right? So again, this is the overall concept, and let's sort of break this down step by step. Okay, so the first thing we have, again, this is our Azure scenario. So we have a site-to-site VPN configured between our on-premises network and our Azure network. We're running this on 2 separate subnets, of course. In this example, I'm using Windows RAS for that connection, but we do support other VPN devices. So once I have connectivity between the 2 environments, the first thing I'm going to need to do is I have to establish directory services. In this example, what I've done is I've taken the on-premises directory and I've stretched it across to a secondary site. There are pros and cons to that approach from a security standpoint. Maybe you're not comfortable with that. You might want to consider something like a resource forest where you're, in essence, creating a DMZ and bringing it back in. Those are just options to consider. Once you have directory services in place, now you have to think about your cloud services design. So again, what you want to do is you want to have a dedicated cloud service for your SQL servers, a cloud service for your SharePoint services, and then finally a cloud service for Active Directory. Once you've created that, and you're going to go ahead and you're going to deploy that infrastructure. The first thing to consider is you have to create a Windows cluster for always-on availability. So again, this is not SQL clustering, this is a Windows cluster. We fully support creating multi-subnet clusters. It's fairly easy now in Windows Server 2012. So what we're going to do is we're going to establish that cluster across 2 instances on the on-premises side. Plus, in addition, typically you want to go with a node majority, so you're going to have a 3rd node, a file server somewhere that's a part of that cluster. And then finally, we're going to have at least 1 replica on the Azure side. You may want to think about your requirements for DR. If you fail over to your secondary environment, you may have high availability requirements there as well. Depending on the amount of time you're going to be running in a disaster mode, you may want to have the additional SQL servers ready to go so that if the disaster does occur, I could establish SQL always on, high availability on the DR side as well. Once we've set up the primary and the replica, what we're going to do is we're going to establish multiple availability groups. And so the reason why we recommend availability groups or multiple groups, because we have different requirements for different types of content that we're replicating. So for instance, for the databases that we don't support async rep for, the configuration database, the admin content, that's for AG group 1. So we're going to configure that for high availability. We can synchronous commit that replica, but we can't ship it across over to the Azure side. Then we have the other service applications. So this is the UPA sync, which we're not going to be replicating, so we put that in availability group 2. Again, we want high availability, we want synchronous commit, but we don't want asynchronous commit on those databases. And then finally, you have sets of databases for your content, and depending on the scale of your environment, you may actually have multiple availability groups, and in fact, multiple instances of SQL servers to support your needs. But we've separated out the content in an availability group, and then finally, the remaining service applications that you saw that we do replicate. So a couple things to note. So one thing to consider is your network design when you're configuring this. So the first thing to think about is when I configure always-on availability between my on-premises environment and Azure, I'm going to go ahead and create that availability group. The first thing that SQL is going to do is it's going to recognize the cluster and say, great, you're running multi-subnet, we support that. And it's going to ask you, all right, so what do you want to use for your virtual IPs or your clustered IPs for your listener? And the only option you have is static, right? So if you think about it, if you have a single subnet, you can do DHCP, but if you have multi-subnet, in this case, static IPs. The implication there is we don't have IP reservation in Azure yet. So what you have to think about is create a subnet that potentially is a little bit smaller, right? That's only going to host your SQL servers so that you have the excess IPs that you need and you're not going to be provisioning new machines in that subnet. You don't want to run the risk of potentially using one of those IPs for that cluster. The other thing to consider is the disk design that you're going to go with in an Azure environment versus what you would build on premises is usually quite different. So let's take the example where we talked about the t-shirt sizing for the VMs. Well, on the Azure side, we go with an A7, right? So this is one of our largest VMs. You have the option of spinning up at least, or at most, 16 disks for that VM. If you're paying for that, you definitely want to leverage the option to use all 16 disks. That's going to give you better I/O. You're going to spread out your data files, log files appropriately across all those spindles. Well, what you get on the Azure side then is, this wonderful array of disks, E through whatever, right? Whatever you decided. That's not typically what you would have set up on the on-premises side. Typically, what you'd have is, some sort of mount point aggregate, right? Some sort of RAID that you would have on the on-prem side. Well, we wouldn't recommend that you do that software RAID on the Azure side. So what you have to think about is, I need to have the same disk structure that I have in the cloud on premises for this to work. Right? So when always-on availability, when it's starting to do the synchronous replication, it's going to look at the same location. It's going to assume the same data files are in the same places on both sides of the fence. So keep that in mind. If you've established your on-premises side first, that may be something you have to potentially re-architect to get this to work in the cloud. So now, let's talk about how this conceptually works. So we've built out our on-premises environment, and now we have the warm or cold standby SharePoint farm in Azure. The first thing you're going to want to do is you want to make sure that your environment's up and running and healthy. So you're going to use temporary databases when you provision this environment. So pretty much everything that you're replicating, the service applications, your databases for content and apps, all those things, provision at least one, use temporary databases, use a naming convention that hey, this is just the temp version of these, so that you can bring the farm totally online. You can do some functional testing. You can run your SPRAS and make sure that it's healthy. Once you've done that, then you configure always on. Right? So now we have replicas that are being shipped over on the Azure side. So we're using asynchronous commit, at which point then we want to actually bring that environment online. So what we would do and what we recommend is that you invest in some automation like PowerShell to provision new service applications with those replicas. So for instance, Secure Store, MMS, all the other databases that you replicated, go ahead and provision brand new service applications using those existing replicas. Once you've done that, the next thing you can do is create a new proxy group. Right? So if you think about it, I've got the old proxy group, everything's nice and healthy, I know that works. Here's this new proxy group with new service applications and some new proxies, plus a few of the old existing ones that we didn't replicate. At which point then you're going to test to make sure those services are up and running, and if you're confident of that, then you switch your web application over. So again, what does that process look like? First thing we have to do is make sure you've set your databases to read-write mode, right? So at which point you've broken now always-on availability. Now you have your replica, which is now your primary. You may have additional instances where you're going to be reestablishing a new AG group in the cloud. If you're replicating your content databases and you've attached them to your farm and you're shipping content that way, you're going to have to run PowerShell to refresh that site map, right? So we have technical examples of how to do that. If you haven't attached it to the farm, they're detached and you only attach the event of disaster, you don't have to worry about that when you actually mount. It's going to take care of that for you. We talked about the next step being provisioning those service applications and those proxies, putting it into a new dedicated proxy group. On the search side, in our case, we're assuming you want full fidelity, so it's a full backup and restore of search. We then, once we have the new proxy group and all the services are running, we then move that content and app web application, because we're using one app now in the new PLA model, we move that into the new proxy group. We reconfigure UPA sync, so we configure our sync connections. We then finally run a profile import, run another crawl, and then validate the environment. One thing to consider, though, more so than ever with SharePoint 2013, is the considerations for external dependencies. Right? So if we're all familiar with the app model, provider-hosted apps are fairly common now. So we might have additional infrastructure that we're integrated with, either on-prem. This could be Azure hosted. We could be a hybrid environment where we've configured some cross services with Office 365. We might have additional productivity services to consider, like our link and exchange infrastructure, and then some traditional data sources like databases, web services, whatever might exist on-prem. When I fail over my SharePoint farm, what happens in that case, right? What happens to those services? So there's not one cookie cutter, one-size-fits-all approach to this. So typically, like on the application hosting side, you would have those same applications running on the DR side. For some of these database and services, some things to consider, and I've seen, unfortunately, people get caught off guard by this. If you're not replicating in disaster recovery of your databases that you're integrating with, maybe from a BI standpoint, not only in the event of a disaster are you not going to have that data, but also thinking about your DR failover testing processes. So if your DR testers don't realize that in their DR environment you're connected to live production systems, you might be inadvertently impacting production data. So just keep that in mind. The last thing to really invest in is configuration management. And so this is something that tends to bite people quite often. The more environments you have, the more complexity, the harder it is to operate. Some of the things you want to think about in your operations plans and your governance around change management is how do you manage a change in production to ensure that the exact same change gets into your DR environment. Now remember, we're running a cold environment because we want to realize the benefit of those cost saves of running in Azure cold. So periodically we're going to have to spin up that environment. We're going to have some change processes and change windows that allow us to keep both environments online for a period of time. First thing, obvious one, is the build patch levels, right? So every time we're pushing a CU, an update, make sure you're doing it on both sides. GPOs or machine configuration, right? You're pushing out things through maybe desired state configuration if you're a little modern, or maybe it's a GPO. Make sure that this stuff is actually getting applied on your DR side. Farm configuration, right? If you have manual processes, many of us do, right? Someone goes in, makes a change to a search configuration, or maybe it's the UPA, it's a new sync connection. You have to make sure that that's getting replicated on your DR side. Solutions, so we want to stay away from these, right? So we're hopefully in the new app model, but if we have deployed some things to our farm, it happens to the best of us. We have to make sure that we're deploying things in both environments. Provider hosted apps, again, so that external dependency, that additional infrastructure, make sure that's getting replicated. And as you're deploying things to that, also make sure you're deploying it on the DR side. And then finally, the little stuff that might bite you, right? So the little things, a minor web.config change, maybe it's a machine.config change. All these little things, every little thing that is now different between your production and DR environment can cause your DR environment to fail, right? So you want to make sure that you have 100% parity and that you're testing this often. So how do you test? Okay, so today the approach is either through third-party tool. So I'm sure you've seen all of our vendors here on site. Lots of our partners have great tools to inspect your environment, do asset and inventory management. That can be used to compare environments. If you don't have that in your tool belt, the simplest approach is use a little PowerShell, right? So we've got examples on TechNet. How do you actually inspect the configuration of your farm? It's very easy through PowerShell, dump that into XML, and then through XML comparison tools, you can at least see, hey, do I have differences in my environments? What we're investing in for tomorrow, and again, some of the features are yet to be determined. We want to get to a point where we're using PowerShell desired state configuration. We want to be able to, through a simple JSON model, we want to be able to define what the configuration of this environment should look like down to the individual machine level, and we want to be able to use the framework of desired state configuration to inspect both your production and DR environments. That's coming through the community. You'll actually see that we have a growing community around DSC. If you're interested, please contribute. You'll also see that we'll be contributing some DSC modules for SharePoint soon. Okay, so with that, I think we'll wrap up. If we have any specific questions about how to configure this or any of the tools that we've talked about, please come up to the mic so we can answer those now. If you have any deeper questions, you want to see some demos of this working live, just let us know and we can definitely walk you through it. Appreciate everybody filling out evals. So please, if you haven't, take the time, fill out the eval, let us know what you think. Let us know how we can improve, and we'd love to bring that content to you next time. All right, so do we have any questions? Other than how do you get to the attendee party? Okay.
May I just ask a question?
Yeah, at the mic, please.
Did the Azure Pack configure the VNet as well and the IPsec tunnels?
No, not the VNet.
No. Okay.
No.
Yeah, so typically what we would consider is that underlying infrastructure is more of a general requirement of the data center, right? So, I mean, in this instance, we're only deploying SharePoint, but if you were doing this in a live environment, it's probably going to be SharePoint plus something. So you want to take that equation out of the the SharePoint configuration.
And then through Scorch, was that all PowerShell, or was there some like JSON configuration templates as well to configure the environment?
Well, what you saw was all PowerShell.
All PowerShell.
Yes.
Okay.
Do y'all have that code like open that's inside the runbooks? So if I already have build scripts that deploy my DR and my dev and all that kind of stuff, I'm on VMware, I'm not on VMM, and I don't need all this, but I still want to use Azure for dev and DR.
Mm-hmm.
Do y'all have that code that I can wrap my scripts around that's inside the runbook? You know, the Azure hooks, the deployment hooks?
So the question is, you already have automation, you made investments in VMware, and you're doing that on premises, but now you do want to go to Azure, and so now you're looking at, can we potentially share some of that IP around, how we're doing that automation in the cloud? Okay. So I think we could probably definitely talk about that to see how we can share that IP. And honestly, there's an argument to say that you use a cloud pack for the Azure side, and okay, all right. Okay, yeah, so then let's talk.
This is a suggestion. What would be nice in RAAS, how do you say that? Well,
RAP as a service.
RAP as a service?
RAS.
it would be nice if, when it tells me I have a critical error or a high error, it would be nice if next to it there was a little link to a video on how I fix that.
Sure.
Just a little instructional video on how I do that.
Actually,
How do I
we
move this
have
up?
we have that in place, but not on the same portal. So we are working on the videos that tells you, short videos, how to fix the issues. But we deliver them not on the same web page though. It's called Education as a Service, EAAS, like RAAS. Okay.
You should link it right there.
Absolutely, feedback
That's
taken.
definitely great feedback.
Sure,
yeah.
thank you.
Good idea.
Okay.
Sure.
I've just got a quick one around the, I guess, lack of support around some of those databases. Is the article updated now with the databases that are and aren't supported for asynchronous replication?
Oh, as far as how we publicly release the documentation yet? No, so it's not available on TechNet yet. We do have a few customers that need the information. It's pretty critical, so what we're doing is we're just collecting that contact information, and then we'll, through support, we can give you an email and basically say if we formally support this. Our tech writers are currently in the process of updating the TechNet documentation.
So could I give you my details then?
What's that?
Could I give you my details?
Absolutely,
Then?
yeah, absolutely, yes.
We certainly have a big customer that would be really keen to get that information.
Absolutely, yes. We're more than happy to share that information
Cool.
in an official manner.
And I guess for the like the search databases, for example, that's I guess it's kind of moot, isn't it? Because you'd have to somehow get the index replicated anyway, right?
Correct, yeah. So a couple things to think about from a search standpoint is obviously the index file that's on the farm itself, but then or your replicas. The other thing to consider is analytics, right? So where you can't ship the analytical component of that to the secondary environment. So that's where you have full fidelity backup restore is your best option.
Right. Okay. Cool. Thanks.
RAAS, is that to fill gaps with SCOM, or I guess I don't understand how that fits. And if so, are there alerts? Can I get alerted when my farm gets out of whack?
No, RAS is not meant to replace at least the SCOM, which is again which can be used to generate some alerts when some service is stopped, right? This actually goes a little bit in depth. I'd say in terms of your configuration checks, in terms of your topology. For example, let's take the example of max degree of parallelism for the SQL server, right? For SharePoint, it has to be set to 1. So we do those kind of best practice checks as part of this RAS tool set, and then lets you know which of those configuration options are actually out of line when compared to the best practice recommendation.
So it's an online BPA, I guess, on
Yes.
steroids.
Mm-hmm.
Yeah, that's
Yep.
basically a great way to think about it. Yeah.
Okay, next question. Just another follow-up question on the Azure pack.
Yeah.
For IaaS, are you configuring the storage accounts and availability sets and cloud services as well through that deployment? No.
Not currently, but that's something that we
Okay,
can
so
definitely
you start
invest
with like a foundational deployment of all that stuff?
Right,
And
so-
you come
so-
in and add you do create the VMs though, right?
Absolutely, yeah. So
Okay.
we create the VMs, we configure the farm. What we consider is the required dependent infrastructure is already in place, right? So the network's already there. You already have your VNet configured. You've already established domain services. So that's what we consider to be existing before we start the deployment.
Those APIs are there, so is that coming, or?
Well, so, that's an interesting question. So if you think about it, right, so if I have a Cloud Pak and I've tied in the dependency of, my Cloud Pak now deploys Active Directory, that's great for the first time I run it, but then doesn't make sense every time I run it subsequently. So now I would have a variation of my Cloud Pak, one with, one without. So really I would, I want to decouple those concerns, and I want to have, maybe we have a Cloud Pak for infrastructure. The only thing it does is deploy dependencies, but as part of the SharePoint deployment, I don't think it really makes sense.
Okay.
So one of the reasons that we don't do some of this today is
Yeah.
that on the on-premise world, we stayed away from hardware configuration, so storage and network, just because we don't have enough gear to be able to do it meaningfully for everybody, right? So I can maybe do it for his SAN, but that doesn't help you or you. And now as we get into software-defined networking, either on-premise through VMM and Hyper-V or up in Azure IaaS, then we can write very prescriptive scripts. Okay, that was weird to say, but we can write the scripts to say, yes, we can configure all of it end-to-end. We're just not there
Okay.
yet. What we want to do is basically lift what we have on-premise to Azure IaaS, and then go back in and fill in all the other gaps.
Yeah, I mean, we have full automation for Azure IaaS, but we don't have the piece configured for the VNets yet. Just can't figure out a way to do that. I don't know if there is a way. So I was wondering about that. And I guess you're right with the cloud services, right? Because we could do that through PowerShell. We could just tie that as another entry in Scorch, right, through the same provisioning process. Okay.
That's how we do endpoints today.
That's how you do endpoints
so
too.
Scorch does the endpoint, and then creates
Okay.
creates the VMs, and then does the